Hello students, welcome to Math Fam. So this is our topic exponential function. We have already seen what is the meaning of quadratic function. So this is again very important part which is part of standard and extended math both. So what are we going to see in this topic here? First, we'll see what is the meaning of exponential function, and whenever you relate to variable where the one of the variable is in the exponent form or index form or power form. So here you can see y is equals to a times b, which is b to the power x, where here x is in the power, where a can never be equals to 0 also. We call it in the as the exponential function, or sometime y can be written as function of x, which do we take the introduction, how do we use the standard form, we will see that. Then after that we will see how the graphs are made for these exponential function, because graphs are very important. You will see later on how do we take the graphs in the transformation topic also. Then you will see in terms of growth and decay that you have learned the compound interest formula, that you use the same formula, you use it for the exponential growth or exponential increase or decrease. Then here, what is the exponential equation, how do we simplify those equation, and then we will take some past paper questions, exam based practice questions also. So let us start our session here. So first thing, whenever we take here any exponential function, so here when I take exponential function here, the exponential function is a function. Function means whenever you are relating two variables in which the variable occurs as a part of index or exponents. So here one of the variable here you will see always, you can see some example here, fx is 3 to the power x. So fx is nothing but y and x is power of 3 or 3 raised to the power x. Here gx is another function which is written as 2 to the power x minus 4. So you can see again x is in the form of power. Here also you are adding 6 and it is 5 to the power minus x. Again in this place x is there in the exponent or index form. So what do we take here? Whenever we take here exponential function, you need to know that the standard form is always taken as y is equals to a times b to the power x, where a can never be equals to 0, otherwise your whole exponential function will become 0. Now here, because the y value depends on x, or you can write down this as fx is equals to a times b to the power x. B is always greater than 0, because see, a cannot be equals to 0, b is always greater than 0, and b can never be equals to 1, because if b is equals to 1, then 1 to the power anything is 1. You are going to get the one fixed value, because if b is equals to 1, then y will be equals to here a, right, and it will be a horizontal line. So here you will see the two cases here. B can be less than 1 here and greater than 0, and here b can be greater than. These two cases you will see the b values. Then here if you will see, we can write down here this y in the form of fx. Here fx is equals to a into b to the power x, so it's the same thing whether you write down y or fx. So again when you see here, a represents the initial amount, because what is the start value? Whenever you are learning the compound interest formula, the principal is known as the initial amount. Here this one, the real life application you will see in the compound interest formula, because here compound interest formula you have learned this as 1 plus r by 100 whole power n, right? So here whatever the outside value p is there, that is taken as the initial amount, or any initial value, original value, since the growth or reduction or decay factor. So whether, if you will see that if the value of b is less than 1 but greater than 0, then you will get it here decay. If it is greater than 1, then you will get it here growth, because here if you'll see this formula, more than 1 it is going to be growth, and if it is less than 1, then it is going to be, that means there is another one formula also in exponential increase or decrease. If you remember here, p times 1 minus r by 100 whole power n. So this is a real life application. You will see that. Then other than that, here x is the independent variable, because the x value is going to decide the y value here. So x is independent variable, y is known as dependent variable. One example, Here, if f of x is a function, it is an exponential function which is given in this form. So sometime we can directly, you should know how to find out the value at particular place. So if in the first place f of 0 means here, what happens if x is 0? Then you will substitute, because this you learn in function here. 2 to the power 0 is nothing but 1, because here you have to remember all the laws of exponents. 2 to 3 minus 1, answer is 2. If I take here f of 3 means here your x value is 3. So wherever you see x, you can substitute 3. Now here, as per the exponent law, you should know a to the power minus n is 1 by a to the power n. 3 minus 1 by 2 cube, because you won't be able to simplify here if power is negative. So I can make it positive power. This is actually here 2 by 1 is the base, where minus 3 is exponent. So if I take the reciprocal, it becomes positive power. So I can take this 3 minus 1 by 8. You can now find out the LCM, which is 23 by 8. So this is going to be your value. After that, how to get here? Sometime we can get the value, the power of variable, it's given as minus x. So wherever you see x, you need to substitute minus x. So that will be 3 minus 2 to the power minus of minus x. That means this becomes 2 to the power x. So your function here, if you see, it has changed. It is still in the function form. We are not getting any numerical value because we are not substituting any numerical value. So this is called finding the value of the function at some particular point. Now, how do you take here growth and decay? So first thing, exponential function means f of x is a times b to the power x, or y is equals to a times b to the power x, where a can never be equals to 0, b value is always greater than 0, and b cannot be equals to 1. So there are going to be only the two cases here. If I take here case 1, when your b value can be greater than here 1, and the case 2, it will be there here when the b value lies between 0 and 1, right? So this, whenever this is true, we call it as here growth. That means here, whenever we are having b value, it can be anything, but it is going to be more than 1. And similarly in case 2 here, because it is less than 1, so b value here can be greater than equals to between. This means it can be in the fractional form. So here this is called decay. Here this is going to be always proper fraction. Here it is going to be proper fraction because it is between 0 and 1, so it's known as proper fraction. Or it can be in decimal also, which is less than 1 and greater than 0. Here also the value can be in decimal here, so automatically, because it's more than 1, you will always get it in the fractional form here. Improper fraction, you are going to get it, or value can be greater than any decimal which is greater than 1. Decimal or whole number, anything you can get it, right? So where do we use this growth and decay? It's very important formula here, the compound interest formula that you have learned as exponential growth increase or exponential decrease also. So this formula, if you remember here, compound interest formula, exponential increase, that is going to be y equals to a times 1 plus r to the power, here it's given x, so I'm taking the same thing. This is called growth, exponential growth, right? So here exponential growth, and this is exponential decay formula also you have learned in your lower grades as compound interest or exponential decrease or increase, where you take whole power x. Now r is nothing but growth rate. That's why if you remember the compound interest formula, again we have taken p plus r by 100 whole power n. So n represents here x, because you are relating here three values. So here p value will be given because it's the initial value. So these two things, how do you use to solve the question? So let us take one example here. You have to model, you need to know what is the initial value, you should know what is the growth or decay rate and how the graph will look like. So here it's written the population of a town was estimated to be 38,000 in 2015. Since then the population has increased each year approximately by 2.4%. Determine the growth factor B. Now here this is known as growth factor. So whenever you are having this formula here, growth factor means it is 1 plus R, where what is your decay factor here? Decay factor is 1 minus R. Right? Now how are we going to take it here? If I need to find out the first part in this case here, growth factor, which is growth factor B, how are we going to get it here? 1 plus R, and R is given as 2.4%. So 2.4% means 2.4 by 100. So 1.024. So this is your growth factor. Now growth rate is 2.4%. Growth factor is 1.024. After that, what do we need to find out here? Write a function to model future population growth. Right. So first thing, what is the formula? Exponential growth formula. You can write down here y is equals to a times 1 plus r to the power x, and 1 plus r you already got it here. Initial value in the starting the population was 38,000 times 1.024 to the power x, so which is representing the exponential growth in population model. Now here x is nothing but here number of years, and what is going to be a y here? Y is nothing but total population. Yeah, total population after x years. After x years. So this is your part B, because you need to model the function. Use your function to estimate the population to the nearest 100 of people in 2030. So here if I'm taking this, if I am already having this as the formula where x is the number of years. Now 2015 to 2030, first we need to find out x. So 2030 minus 2015 will be for 15 years. Now if you substitute the value, you will get it. What will be the population in 2030 times 1.024 whole power 15, and you will get it here approximately here 54,000 here 234.4, because the population we generally don't write down in decimal. So if you do the rounding of here to the nearest 100, which population will be 54,200 approximately. These many people will be there in that town. Here 1 plus r, which is b, it is greater than 1, then you always get the growth. Now let us see another example. It says that Sarah bought a car for $15,000. So here the cost price here is given as $15,000. Its value depreciates, loses value by approximately 15% each year. Every year 15% decrease means it's going to be exponential decrease, because from the new value 15% decrease. Then in the second year again from the new decrease 15% below than the current market value here. So find the depreciate decay factor. Now first you have to remember, whenever we are having this, the exponential decrease formula is this here, 1 minus r. So this is called decay factor here. Decay factor is nothing but here 1 minus r, and r is the rate of decrease at which the value is decreasing here. So it's a 15 by 100, which is 1 minus 0.15, which is going to be 0.85. Now if you will see the value of b, this is decay factor, which is value of b. So that's why a times b to the power x, your b is 1 minus r, which is decay factor. So here if you will see again, it's a less than 1 and greater than 0. That means it's a decay factor, or there is a decay exponential exponential decrease. Now what is written here? How to write down the function to model the future value of the car. So y is equals to here a times 0.85 to the power x. Now the start value, the original value was 15,000. So my model will become here y is equals to here a is $15,000 because that's the original value. So you'll get it here 15,000 times 0.85 to the power x, right? So here, how are we going to do it now? Next question says use your function to estimate the value of Sarah's car after 3 years. Now x is the number of number of years, and y is the value here, right? So I can take it here x as 3. So y value will become here 15,000 times 0.85 to the power 3. And when you do the simplification, your value should be less than the original value, which is 15,000. Whereas in growth, the final value should be more than the actual value. So you are going to get here the value approximately as 9211.88 dollars. So you can see that which is less than here $15,000, which is approximately equals to 9,212 here approximately. Now this is the basic exponential function graph. If you see this example, it is y is equals to 2 to the power x. So this is a function y is equals to 2 to the power x, or f(x) is equals to 2 to the power x. It's the same value. So what is your initial value, a value? It is 1. So this can be written as 1 into 2 to the power x, which is f of x. So you can relate it with the learn function where you have learned y is equals to a times b to the power x. So your initial value is 1. Now they are substituting here different value of x because it's independent value. Then you are getting here y is different set of specific value of y. Now here if x is 0, y is 1. Now here if you will see x is increasing, then y value also, or fx value is also increasing exponentially. Whereas when x is decreasing here, the y value is also decreasing exponentially. Now here if you mark all these values on the graph, your graph is going to look like that. Here first it is the highest value, slowly y keeps decreasing, but it never meets x-axis. That means it is never going to cut x-axis. So what are the observations do you see here when y-intercept here in this case, because my function is f of x is equals to 2 to the power x. So what is going to be your y-intercept here? It is here 1 because 2 to the power 0 here. Y is equals to 2 to the power 0, which is 1. So your y-intercept is 1. Now if you will see, the graph is totally here. Graph is above x-axis. Above x-axis means all the xy values are greater than zeros, right? The whole y-axis here, the values here, all the y values are above 0 means it's going to be the positive value. What is going to be the domain? Domain means value of x. So here you can take any value of x. If you are taking here, you are getting y value always greater than 0 here. Domain means the value of x here, the value of x, all the values of x that belongs to R. Whereas range means the y value here, the y value or f of x value is always here, y value is greater than 0. You will never see that equals to 0 because here y is equals to 0 and it is not cutting the horizontal line. That's the second one. So here if I say here, if value of x gets smaller, the value of y also, it is decreasing exponentially, right? So here value of y also decreases, but never becomes 0. Why this is true here? If you will put the logic, never becomes 0, because if I'm having y is going to be equals to 2 to the power x, there is no such value of x which can give you y is equals to 0. Y can never be equals to 0. It can be here always positive. It can be coming near to 0, but it never becomes 0. So because this graph is never going to cut y is equals to 0, that is why now the asymptote word will come. That means the value tends to 0. But here we will never get 0. So for which value we are never, it's never going to become 0 here. Y is equals to 0. So what will become here? So we say that here, because this is the equation of the line. If I say here line y is equals to 0, which is x-axis, right? This is the equation of the line, is known as is a horizontal asymptote. So this is your new word here, asymptote of this function. So you are getting here x or y is equals to 0 as the horizontal asymptote. See, this is the graph of y is equals to b to the power x. Now what happened here? X gets larger because this is for the decay, right? Here, whenever it's less than 1, greater than 0, this is called here decay factor. It becomes decay factor, and your graph is going to become here. Now x value is increasing, y value keeps decreasing here, right? This becomes here y is equals to, now it is less than 1 means it can be in the fractional form, anything which is in fractional form. So if I'm taking the same value here, so if I'm taking here 1 by b to the power x, or I can write down here y is equals to b to the power minus x. So same thing here, the power, if it is negative, you can write down negative power in the fractional form. I can reciprocate the base. Also both is representing the decay graph here, right? So here you can see that y is equals to bx is a horizontal asymptote. Your asymptote is same, because now here x value is increasing, y is decreasing, but it will never cut x-axis here, which is y is equals to 0. So your asymptotes are same, but it represents the reflection. Here this is the growth factor. The growth factor graph is always on the increasing side here, like this, and the decay factor graph will always go like this. So here also you should know what is the y-intercept. It's coming here 1, and asymptote, horizontal asymptote is y is equals to 0. In this case also, if you will see, the y-intercept is same and the horizontal asymptote is y is equals to 0. We have taken the previous example as y is equals to 2 to the power x, and here this one is nothing but the growth factor right here. Now if I take y is equals to 1 by 2 to the power x, or here I can write down y is equals to 2 to the power minus x, because it's the same thing. Now here this becomes here decay factor, because it's a less than 1. So sometime less than 1 you will see the base same, but the power becomes negative here. This is your decay factor. So how the graph will be? So here if you will see, it's written here f of x is equals to a to the power x, where a is a positive constant and a can never be equals to 0. So if I take the example, this is 2 to the power x, this is 2 to the power minus x, or 1 by 2 to the power x. So here you will see that if the y, how do we say here? If the x value is decreasing, y is decreasing, but it never becomes 0. Here x value is increasing, y is decreasing, but never becomes 0. So y is equals to 0 is the asymptote, and your y-intercept is going to be here 1. So what do we take here? Y-intercept is equals to 1 in both the cases, because you can see that also, and in both the cases you are getting here horizontal asymptote. Y can never be equals to 0 here. Y can never be equals to 0. That is why here that becomes your horizontal asymptote. Or here f of x cannot be 0. So whatever value is not possible will become asymptote. One more thing, if you will see here, this is nothing but whenever we are having here this case, you can see that here this is reflection on through y-axis, because here through y-axis, because here f of x is equals to 2 to the power x and f of x is 2 to the power minus x. It is reflection through y-axis. Now here if you will see, these are exponential function, right? So all these things if you will see, these are the graph. There are C A B C D here, A B C D, all these are going to be here, decay representing exponential function representing decay here. Now here if you will see all D E F, you will see that then this is representing using the exponential function using the growth factor. So here how are you going to identify? So first thing, because if you will see this is in the form of y equals to a times b to the power x. Now here a is 1, so it is nothing but it is in b to the power x form, and b is nothing but here we know as it is growth or decay factor, right? So how are you going to find out which graph is representing which exponential function? Now you need to know that here if growth greater the growth factor here, greater the growth factor, then you will get steeper the graph. Okay, steeper the graph. So first here, and whenever growth factor is greater means which kind of what has to be b here, b has to be greater than 1. So first thing you identify among all these things here, 3.6 is the growth factor. So this is growth using, it's going to be representing exponential growth function. Now here this is less than 1, we can't take it, between 0 and 1. Now this is also going to represent here C, but also going to represent growth here. Now here it's given in the fractional form. You can write down in the decimal form also to understand. It is something 0.66 whole power x. This is 2.5 whole power x. Now here also, because it's a greater than 1, it is going to be the growth factor. So your a, b and f are going to represent your growth factor. So I just now I said steeper the graph, whenever you are having greater the growth factor, steeper the graph. So what is going to be 3.6 is the greatest growth factor. So the steepest curve here, it is, so D curve is going to represent the first exponential function. E and F will be among C and F here. So 1.5, 2.5, 2.5 is the greater value. So this E graph is for the F bit, and F graph is going to be for here C bit, right? So this is for the growth one. Now whenever there is a decay exponential decrease graph, it goes like that. When the x is increasing, y value decreases, but it never becomes 0, right? So y cannot be equals to 0. If you see graph CBA, now here whenever there is a decay factor, there will be here, because it's a decay here, you will say that here smaller the decay factor, steeper the graph. This is just the opposite here, steeper the graph. Right, so among this here, if you will see 0 0.9, 0 0.25, 0 0.6, what is the smallest value here? 0 0.25, which is 1/4. So C graph, because C among A, B, C is the steepest one, so it is going to be representing the D bit exponential function. Then 0 0.9, 0 0.66, it is going to be B graph is representing the E bit exponential function, and A is going to be here for part B. Now, other than that, sometime you will see that here different types of transformations. So translation also will be there. The exponential function, sometime you will see it in the form of a. Till now you have seen a into b to the power x, where most of the time a was 1, then plus c. So here again a is the initial value, right? So here we have seen that a is the initial value, then b we have seen it as growth or decay factor here, or decay factor. Now C value, if you see, how will you identify what is C value here? So that is called vertical translation here, vertical translation or movement here, translation, or because it's a vertical translation or movement, you can go here up or down, right? So going up will be the positive part here. It will be always positive, and going down is going to be subtracting from the horizontal asymptote. Now, what does that mean here? See here, if I'm writing asymptote, right? So here, whenever we are having this, how can we take it here whenever we are taking the same function? Like here, if I have taken here y equals to 2 to the power x plus 3. So first you know that all for everything the horizontal asymptote is y is equals to 0 is the asymptote for this case. So how the graph will look like if I sketch the graph for this part here? You know that this is x-axis, this is y-axis, and for 2 to the power x, if I draw it here, this is for, if I write down y equals to 2 to the power x, where y is equals to 0 is the horizontal asymptote. Now, plus 3 means there will be the movement here 3 units above. Now, here if you see, because 2 to the power x, the y-intercept is 1. So, this is 2, this is 3. So, first you draw the horizontal, because your asymptote will change now. The whole graph is going to move up by 3 units every point here. So if this is y-axis, what is going to be your graph look like here? Because now your asymptote is here, this is 3 here, and where is going to be y-intercept? It can be 4. So your graph of this will look like here. This is 4, it will be y-intercept. So this is y equals to 2 to the power x plus 3, where this is your asymptote is moved. So what you can see, remember this, if there is a plus c, that becomes the new horizontal asymptote instead of y is equals to 0. This means here every point on this actual 2 to the power x graph has moved 3 units up. So everywhere it is, every corresponding point has moved 3 units up. Similarly here, if I say the same thing, because you can move down also, if it is 2 to the power x here minus 2. Minus 2 means it will move down here. So from a horizontal asymptote, which was y was 0, if you will come down here, then it is going to be minus 2. So first you make here what is going to be y equals to minus 2. This is y equals to minus 2. So your graph from the actual place, every point is going to move 2 units down. So here your y-intercept will become minus 1, and your horizontal asymptote will become here minus 2. So your graph, if you take it here, the graph will be, this is all sketching the graph. Exact graph, more than exact graph, it's important that you should know how the sketch will look like. So here, this is going to be your graph of y is equals to 2 to the power x minus 2. That means there is a movement of 2 units down. Every point on the original is moving 2 units down here. So that is why it's a negative 2. Now here sometime you'll have the different types of transformation. I am just telling you the reflection through x and y axis. So here if you will see, what is your basic function f of x or y, which is equals to 4 raised to the power x. Now here if there is a minus sign means it is going to be reflection here, reflection through x-axis, through x-axis is going to be equals to, here y is equals to minus 4 to the power x, because here there is a minus sign, right? So and here if I'm taking the other one, the part b here, if I take it here, we have already seen when y is equals to 3 to the power x, this is, and here this is reflection of the function through y-axis, because here the sign of power is changing here, so that will be through y-axis. So y is equals to 3 to the power minus x, it's reflection through y-axis, and here it is reflection through x-axis. So how are you going to sketch the graph? Both the graphs you need to first find out here y-intercept and asymptote. That's the most important part here. So if I take it here, what is going to be y-intercept? Where the x value is 0 will become here minus 1, because 4 to the power 0, it will be 1 and minus sign is outside, and here y-intercept, if you will see 3 to the power 0, that will become 1, right? Now after that, here if I take here, how will you identify the horizontal asymptote? Horizontal asymptote here, asymptote, which value y can never become 0. So y is equals to 0 here, because there won't be any value of x which will make the function y or f of x as 0. Similarly here also there won't be any x value which will make y as 0. So your horizontal asymptote here is also, this is y is equals to 0. So whenever I am making the graph of these two cases, let us, if I need to sketch the graph here, first if I draw 4 to the power x graph, right? So what is the y intercept for 4 to the power x? You know that this is your 1, and the graph will look like this here, which is going to be here like this, y is equals to 4 to the power x. Now because it is becoming minus sign initially, that means it is going to be reflection through x-axis. Reflection through x-axis means this is your y is equals to 0. That means every point, what is where you are having 1. So what is the reflection on 1 of 1 here? It will be here minus 1. That means the graph is going to be reflected through x-axis, and your y-intercept will become here minus 1, and the graph of y is equals to minus 4 to the power x. There's your asymptote remains same, but y-intercept has changed. Similarly, in the next bit, if you will see here, if I'm taking this is y is equals to 3 to the power x is the basic function here, and it is reflection through y-axis. So here if you will see 3 to the power x is the main function, so which is growth, that represents the growth, where there also the y-intercept is 1. So here if I take it, this is your y is equals to 3 to the power x. Now, if I do the reflection through y-axis, here 3 to the power minus x can be written as 1 by 3 to the power x. So, your y-intercept is same, right? So, here it will be reflection. So, reflection means whatever the distance of every point, it's going to be here same. So, if I am taking this, it will become like this here. So this is it keeps decreasing here, right? So this is your graph of y is equals to 3 to the power minus x. That means whatever distance is there from the y-axis, this distance is same. If I'm talking about the horizontal here, reflection through x-axis, whatever distance of this point is there, the same distance should be from the other corresponding point also. Now, exponential equation we have earlier also seen, but we will have this topic here as well, because we are learning about exponential function. How do we simplify these kind of equation? Wherever the exponents, the equation is given in the exponent form. So here what is given here? The exponential equation is an equation in which the unknown occurs, unknown means variable occurs as a part of index or exponent, like 2 to the power x is equals to 8. Right, so how are you going to the value here? If it's written here 2 to the power x is equals to 8. In this case, what do you do? How do we simplify this? We try to write on both sides of the equation with the same base. That means both side of equation, until unless it's having the same base, we cannot get the value of unknown or variable. That means see here a to the power x is equals to a to the power k, then you can equate x is equals to k because their bases are equal. Now 2 to the power x is equals to 8. So Wherever you see composite number, write down in the exponent form as per your required base. So now the bases are same, therefore x will be equals to 3. Similarly, here it's written here 30 times 3 to the power x is equals to 7. I need to get here the value of x here, but some cases, in this case here, if I'm writing here 3 times 10 times 3 to the power x is equals to 7, because 10 is having factors as 2 and 5. So we can write down here there's no power, 1 is the power, 3 to the power x plus 1 is equals to 7 by 10. But in these kind of question here, because here 3 to the power x plus 1 is 0.7, in this case right hand side there's no possibility that you can make the base as 3. So this kind of question, the logarithm will be introduced to you, because using logarithms you are going to solve it. So here in exponential equation we will see how to make, in these kind of question you need to just make the same basis to get the value of unknown. Here if I write down this, first thing 4 is a composite number, 8 is a composite number, write down in the exponential form. So 2 to the power 2 whole power x, other values write down as it is, x to the power 2 to the power x plus 2 is equals to 2 raised to the power x plus 1, and 8, the base can be written as 2 cube whole power x. Now open the bracket here, power to power you multiply the power, so 2 to the power 2x by here 2 to the power x plus 2 is equals to 2 raised to the power x plus 1 by 2 raised to the power here 3x. Either you do cross multiplication here, I can do, or I can subtract the powers also. If I subtract the powers, same side powers must be subtracted here, which will be equals to 2 to the power x plus 1 minus 3x, because we are applying the laws of exponents. Whenever you divide, you have to subtract their powers. After that, if you will see here, it has become 2 to the power x minus 2 is equals to 2 to the power minus 2x plus 1. Now here if you will see, both side bases are same. You have simplify the equation such that you are having both side bases same. That means you can equate their powers to get the value of x. This is then x plus 2x is equals to 3. So 3x is equals to 3. X will be equals to 1. You can, in these kind of cases, you can verify your answer by equating here. See, if I substitute x as 1, so it becomes here 4 by 2 cube to the left hand side, which is 4 by 8, 1 by 2. And right hand side, if I put 1, then 2 square by 8, which is 4 by 8, which is half. So we are getting both side half. That means my value of the variable is correct. Now let us see here exam based practice questions from the past paper. Here if you will see, the weightage is given here 4 marks. This is from the extended paper. The functions here, this is from extended paper, functions fx and gx. Now when you will see these two functions, you know that this red color graph, it's representing here exponential increase, and this is the exponential decrease graph. Now whenever you see that here, first you have to remember, because your function here, both the functions are given in the form of a b to the power x plus c. Here this is growth or decay factor. Now growth here b will be greater than 1. Here b is going to be between 0 and 1. Right? See this graph. Let us see here. We have already discussed the c always represents the horizontal asymptote, which is the movement here, vertical translation here from the original asymptote. Now a to the b to the power x, the original asymptote here, it is y is equals to 0. So first look at here for the fx graph, which is representing exponential decrease here. If you will see, your asymptote is moving 1 unit from this up, right? So y equals to 0, it's moving, y is equals to 1. So what is going to be the fx first? Can I substitute here a b to the power x plus 1 here, because c is going to be equals to that horizontal asymptote. Now after this, if you will see, this is, now if you see this fx graph is intersecting y at 5. So what is your y intercept? 5. So 0, comma 5. That means when x is 0, y is 5 and fx is nothing but y. So I can write down here 5 is equals to, because we need to get here ABC value here, right? In this question you need to here drag here, find the values of ABC of both the functions. Select the correct values to complete the table. So let us first, if I'm substituting y as 5 here, a will become, we don't know a, so let a be as it is, b to the power 0 plus 1, which is b to the power 0 is 1. So here it is a plus 1 and then a will become 4 here. So what is my graph here? F of x is equals to 4b to the power x plus 1. Till now we got this, right? So what is the value here? If you will see, for the first function, you will drag 4 in place of A. You will drag 1 in place of C. B value we will see, because you know that it is exponential decrease. So it should be between 0 and 1. So definitely it should be 0.5. But we will just fill that later on. Let us find out the graph for now Gx here. Gx, if you will see the horizontal asymptote here, because that is also a b to the power x plus c here, from y equals to 0, it's moving here 3 units down, so it is minus 3. So g of x can be written as ab to the power x minus 3. Now again this graph is also y-intercept is 5, that means you can substitute here 0 comma 5. 5, y value is 5 when x value is 0 minus 3. So it is 5 is equals to b to the power 0 is 1. So a minus 3, so a value is 8. So what is going to be here your gx? The function gx, here initial value, it is going to be here 8 b to the power x minus 3. So if you will see that for the gx here, a is 8, then here your horizontal asymptote, which is the c, the vertical movement, it is minus 3. 0.5 is going to be for this. They have already given here for gx, so it's going to be 0.5. Now this is the next question based on exponential function from the past paper here. So what is written here is skateboard ramp set is built using functions provided in the given diagram. So here the diagram it's given here, ramp 1, ramp 2, and here this is the platform. The diagram is interactive and hover over the intersection of each line. Now what do you need to find out here? Find the value of A, find the value of B, and the C part it says here, find out the length of the platforms. Here how to find out the value of A? Now A on the x-axis, if you will see, this is the intersection. So now here there are three functions, which is the first function is fx, which is going to be here f of x. It's given as 4 to the power x, which is an exponential function. And here if you will see, this is the intersection of fx and hx. So if I find out the coordinates of these two, I can get the value of a. Similarly here, if you will see the b coordinates, I can get it, which is the x. B is on the x-axis, so you can get it if I am able to get the coordinates of hx and gx. So you will use here hx function, which is given as 2, and gx, which is given as 3 to the power 5 minus x, and here hx is given as 2. Now whenever you know that whenever two graphs intersect, any kind of graph it intersects, so you can solve the equation, you can equate their equation to get the intersection point. So here if I take here y is equals to 4 to the power x, this is y is fixed because this is the horizontal line, right, which is parallel to x-axis. So this represents y is equals to 2, which is given in the form of hx is equals to 2. Now if you equate these two, so what we are going to get it here, 4 to the power x is 2, and you know that this is exponential equation. So I have to make both sides same basis. So 4 can be written as 2 square. So 2 to the power 2x and 2 to the power 1. So what if you equate their powers, this one will become 2x is 1. So x is 1 by 2 or x is 0.5. So you got the x coordinate, which is the value of a, right? This is 0.5 here. This is the value of a. And if I am writing here coordinates form, if they are asking anytime here coordinates, then you know that this can be written here 0.5 comma 2 because y value is fixed. Similarly, if you solve the next two functions here, so this is again y value is fixed here, and here y is equals to 3 5 minus 5, 3 raised to the power 5 minus x. Now in this case, when you equate both the sides, 3 to the power 5 minus x is equals to 2. Now you can't make the bases same because left hand side 3 is the base, right hand side 2 is the base, right? And we cannot convert 2 and 3, they will both are prime numbers, so we cannot convert any of the side as the same base, right? So in this case, we use here logarithms. So what are the rules I have to get it? First, you separate the x term. So can I write down this as 3 to the power 5 by 3 to the power x, which is 2. Now, if you write down this can become 3 to the power 5 by 2 is equals to 3 to the power x. And whenever there is any exponents which can be written in the form of logarithm, here if it is a to the power b is equals to c. So base is a, we write down as log to the base a of c will always be equals to b. So here also the base is 3. This is the value which can be written as here, if I am taking 3 to the power 5, 3 to the power 5 can be taken as 243. 243 by 2 is equals to 3 to the power x. So which can be written as 3 to the power x equals to here 121.5. Now if I want to, because right hand side I cannot convert it into 3 base, so we can convert it into log. I can write down here log to the base 3 because base is 3 of 121.5 is equals to x. Now using the calculator, there are two symbols here, log and here it is ln, right? So now whenever it's a log is there means the base is 10, right? So but here we are having base as 3. So what you can do here, you can change the base of 10 by here. So there is one more law. If you will learn log, then you will understand this can be, you can convert it with the base 10 as log to the base 10b by log to the base 10a, log of a to the base 10, right here. So these all there are laws of exponents, there are similarly laws of logs also. So x will be equals to, I can write down here log 121.5. Now log is written means it's always to the base here 10. Otherwise in the calculator you don't have the base 3 log. So this is the way you get it. Now you can use log here. I can take here log 121.5 divided by here. If I take log 3, then your answer is coming it as 4.36907, which is approximately here 4.37. So what is going to be the coordinates of B here? If we were finding here B, right? Because we need to get here B. So the intersection here, it is 4.37 comma 2. So what is the value of B? 4.37. A is 0.5 or 1 by 2. And B here you have to write down, you are calculating in terms of X, but you must write down 4.37. So you got both the values. Now how to get the length of the platform here? You can subtract because B minus A will give you the length of the platform. So you can take it here. This is length of platform can be equals to 4.37 minus 0.5, which is going to be here equals to 3.87 units. Right? This is going to be the length of platform. So this is the way you solve question. Hope you got this.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.